Turns out that radicals are really exponents. It's just that we'll have to be writing them as fractional exponents. Let's start by looking at what the rules are telling us here. So recall that this guy underneath the radical sign, the a, this is the radicand, and this, given as n here, is the order of the radical. Of course, if there's no number there, we know that the order of the radical is 2. It's a square root, in other words. When we rewrite a radical as an exponent, the radicand becomes the base of the exponent, and the order of the radical, the square root, cubed root, fourth root, whatever the order is, becomes the denominator of the exponent. This isn't really new. We've always had a denominator. It's just that the denominator has always been 1, so we haven't needed to make it explicit. In this case, because a is raised to the power of 1, we have a numerator of 1. Remember as well that it doesn't matter whether we write the exponent that the radicand is raised to underneath the radical sign, as we do here, or raise the entire radical to that exponent. The reason for that is when we write it as a fractional exponent, we can't tell which of the two we mean. These are interchangeable. So let's practice this. I've intentionally given each of these questions with a radicand of 2. So the base of each exponent will be 2. We just have to figure out how to decorate it, what the exponents will be. So the square root of 2, I know it's a square root because there's no value there, so I know the order of a radical is actually 2. This is just making that visible. Can be rewritten as the radicand, that's the 2 under the radical sign, raised to the power of 1/2. The 2, that is the order of the radical, the order of the radical. Okay, so what does the cubed root of 2 look like as an exponent? Well, once again, I'll write the radicand as the base, and this time we're raising it to the power of 1/3. Where's this 1 coming from? Well, I think it's easier to highlight where that 1 is coming from by looking at what happens when that numerator isn't a 1, and that happens in the next question. Here we're looking at the fourth root of 2 to the power of 3, which of course we could write as the fourth root of 2 all to the power of 3. So this is going to be the base 2 raised to an exponent. What exponent is that? Well, the denominator is a 4, because the order of the radical is 4. And the numerator is 3, because 2 is being raised to the ordinary exponent 3. Or the fourth root of 2 is being raised to the ordinary exponent of 3. Let's keep going. So here we've got another square root, though we're raising it to the power of 5. So we've got our base. Our radicand turns into our base of 2. That's raised to the power of 5/2. It's a square root. This 2 ends up in the denominator. And finally, the radicand here is raised to the power of 4, but the order of the radical is a 2. Now this one can be simplified. We don't need to take the square root of 2 and then raise it to the power of 4. And rewriting that as a fractional exponent, I think, really highlights that. So this is 2 to the power of 4/2, or just 2. And we're not evaluating in any of these situations 2 to the power of 2. I very much want to write as 4. But the exercise here is simply to rewrite the radicals in exponential form.